Hello everyone, a very warm welcome to all. In this session, we are going to learn about Introduction to Multivariate Data Analysis. Data analysis is a perfect solution for so many issues in case of which will have plenty number of data. Analyzing one variable at a time will not give a complete picture. So our MDA will help us to study multiple variables simultaneously. I am Nandini, working as an assistant professor in the Department of AIDS at Jai Engineering College. With this, we'll start our session. So these are all our agenda for this session. So first we are going to see about introduction, measuring scales and common technique and guidelines. Along with we are going to see one example of MDA. So we'll just start with the introduction. So first, multivariate data analysis. The definition of multivariable data analysis is processing multiple variables simultaneously to understand relationship and effects. The importance of multivariate data analysis is uncover hidden patterns and complex interaction in data, and moreover it is used to make informed decision for any goals or objective. So the applications of MDA will be widely used in economics, healthcare, marketing, environmental science, social science, engineering, agriculture and education. So mostly any industries or any sector will deal with plenty number of data will suggest for MDA. So the next one we are going to see about measurement scales. So multivariate data analysis always depends upon the variables. So we have to collect multiple variables and we have to perform the analysis over them. In order to making a variable, we have a measurement scales. So measurement scales describe how variable is measured and what mathematical operations can be performed on its value. We are having four categories of measurement scale. The first one is nominal, ordinal, interval, ratio. So totally scales are there. So here I am just making a summary over here. So the first one is nominal. It is used to make a data into names or categories only. For example, we can categorize blood groups as A, B, AB, O, like that. So the second one is ordinal. So here data can be arranged in meaningful order or rank. So here we can take the satisfaction of customer or any rating of a movie, like we have to choose poor, average, good, excellent, like that. So the next one is interval. So interval scale is responsible for data which has order and equal difference between values but not actually true. So it just to make a interval from this range to that range. Example, temperature in Celsius. So 10 degree, 20 degree, 30 degree, like that. Finally, ratio scale. So here data can be ordered and it follows equal intervals and it should have a meaningful true zero value. Say for example, we are having a data of height, weight, age and income. So typically this four scale, nominal, ordinal, interval, ratio will only work for the variable categories. So the first two will be responsible for collecting qualitative variables, that is categorical variables. For that we are using this scale, and the last two will be responsible for quantitative variables, that is our metrics. So all the data can be numerical, means will go with this two scale, interval and ratio. Yes, so the next thing is we are going to see about common techniques, how we are conducting the multivariate data analysis, what are all the frequent techniques to employ this objective. So the first one is multiple regression. It is used to predict dependent variable from several predictors. Second one is discriminant analysis. It is used to classify observation into known groups. The third one will be MANOVA technique, that is multivariate analysis of variance. It is used to compare group means across multiple different variables. So the next one is canonical correlation analysis, CCA. It is responsible for analyzing relationship between two variable sets. The next one will be SEM, structural equation modeling. It is described model complex causal relationship. The next one is factor analysis. It is used to reduce variables by identifying latent factors. The next one is cluster analysis. It is used to group similar cases without any period labels. The last one is multidimensional scaling. It is used to visualize the data similarities by histogram any bar charts. So these are all the common techniques. Here I am just representing as a summary. So it's just a technique and what are all the main feature and description of the technique. Okay, yes. So the next we are going to see about one example. So here I am taking a case study of predicting house price analysis. So in order to predict the price of the house, so definitely it should involve several factors. So I can take four variables along with the house price as a fifth one. So the first one will be a house size, the next one will be number of bedrooms, next one will be age of house, and the fourth one will be distance from the city. Finally, I am just involving my house price as a variable. So here we are just simultaneously study all these five variables together. The question is how these four variables are influencing the house price. So this is what the issue. So here I am just giving a solution as multivariate regression model. So this technique I am just going to exploit this issue in order to predict my house price. So the linear regression model formula will be y equal to mx plus c. It is for linear. If in case of multivariate or multiple regression model means we'll just involve with the multiple variables. So here I'm just using A plus B1 size plus B2 bedrooms, number of bedrooms, and I have to eliminate the age of the house and the distance of the city. In order to predict the house price, you have to use this formula. So better it will help to predict the nominal cost of your house price. So this is how we are predicting the house price by using MDA techniques. Hope so you can all get the point, right? Yes. So the next one we are going to say about guidelines. When performing multivariate analysis, it is important not only to obtain statistical result but also to understand, evaluate and interpret them correctly. The following guidelines help researchers to make reliable conclusion. We'll see one by one. So the first one is practical and statistical significance. So this first guideline check both whether the result is statistically significant as well as it is should practically significance. That is, it is meaningful in real life. So the second guideline will be sample size. So remember the sample size affects the statistical significance, reliability and stability of the result. So always carefully you need to choose your sample size. It could not be too low or too high. We need to make a moderate sample size. Third one will be know your data. That means we have to analysis a perfect dimension of the data. Understand your variables, measurement scales, missing values, outliers and distributions before analysis. So the fourth one is model parsimony. So here it is prefer the simplest model that explains the data adequately. Avoid unnecessary variables. Also, we know we need not to do any complex relationship among the variable. Preferably, we just choose a very simple model. The fifth one will be errors. Errors are the main significance to validate your analysis. So we have to carefully examine residuals and errors to identify outliers, poor prediction and problems with model. The sixth one will be simplify models by separation, breaking complex analysis into simpler parts to understand relationship clearly. So the last one is after performing all the analysis and if you get the result, we need to validate the results. So we have to test the model using new data, cross-validation or replication to ensure the results are reliable. So always when we are conducting the multivariate data analysis, we have to follow the 7 rules. Then only we can achieve a correct solution to the problem. So finally, we are just coming to end of the session. So far we have discussed what is multivariate data analysis, then what are all the measurement scale, finally the common techniques with guidelines. So we can tell multivariate data analysis involves analyzing multiple variables together using appropriate measurement scales and statistical technique while ensuring the results are meaningful, reliable, simple and validated. So I hope so you can get some more information about MDA. I hope so this session will be informative and helpful to your studies. So thank you. We'll see you on the next section. Thank you so much.